This afternoon, I'm gonna talk about unlocking your serverless functions. So let's start. First, I have to ask something about, like, could you raise your hand if you are use sometimes serverless functions? Are you familiarized with Kubernetes? Docker? Yeah? Okay. And AI models, some kind of artificial intelligence. So, well, about me, first, I am a professor in Guatemala. I teach operating systems. I also make some DevOps consulting in Guatemala, Central America, to be in context. I also work in e-learning site, like kind of Coursera, but for Spanish people that speak Spanish. I really like the things about architecture and that kind of things, like cloud, AWS, Google Cloud, all that kind of things. So the main idea of the presentation is to share the thing that I learned in a consulting that I made for the telecom company, a big telecom company in Latin America, to be specific in Guatemala. So that application was using Telegram. So first, all the architecture of the application, you can use it for WhatsApp, Telegram, Facebook, all different kind of instant messenger kind of services. And the needs for the application was first, integration for new technologies. They are kind of migrating for new technologies like Kubernetes. They are using AWS. They need a very short time of development. It's the big challenge for all the corporations. And then the implementation about DevOps and some kind of tools that we are familiarizing in some kind of things like Jenkins or that kind of platforms. So, of course, you have to spend less money in infrastructure. And the performance is very, very important, and also the availability of the system. So that's the needs of that system that telecom company made. So the flow of the chatbots first are maybe like 6 steps in summary. The first step, you have to read some parameters, for example, to create like a kind of language. Then if you use artificial intelligence, you can make or compile like a kind of model, yeah, like TensorFlow, that kind of thing. Then you can use a kind of platform for serverless function like Lambda or something like that, like Azure functions or Google Cloud functions. And the first step, when you choose that kind of technology, you have to deploy your code in that infrastructure. So in the 5 step, all that kind of services, you have to link your solution with the API of that service. You have to link it. They call to set the webhook. So in the end, you have to do some monitoring and for your serverless function to display your data, what is happening. Here is the big challenge. I'm gonna be here. So you have to do some kind of visual programming. For example, we know how to programming, like just print kind of commands, read, like input information, like put some values in some variables. And in this diagram is more or less like that kind of visual programming that you have to do. So there's a lot of pieces in this kind of system. I'm gonna show you some diagrams about that. So could be like some strange now. So very like, what is that? So here, this one is the representation about this diagram. It's like visual programming, maybe. It's like you are programming like you have a main part, then it's like a sequence of steps. So the first step could be print, hi, how are you? The second step could be, please enter your age, for example. Then you have to store that value or show it in a print command. And for course, you have to store that value in some kind of database. For example, here is NoSQL database that stores all the information. And this is an example of the language that I invent. So, for example, here is a node that is like the sequence, maybe like the kind of step. For example, for this diagram is the step 1 or the node 1 to 3. You can set some security profiles. For example, because it's a chat, you have to deny some access to them and don't be public and private some parts, that kind of things. And in this kind of diagram, you can structure that information with JSON. So the first part, you have a node, the number node, a security profile, for example, a phrase that you can use to compile a model to detect what are you writing about, and you can jump to that sequence. So in the end of the presentation, I'm going to show you how it works and how all the pieces work together. So continuing with this structure, for example, in a chatbot, you can create this kind of language with different kind of instructions like print, if, jump, read information, and set some parameters like a common language. And you can set some rules to execute the sequence of steps of a chatbot. So it's like a list, more or less, like first execute this node, first execute this other node, and them, to the end. So for this, you can use some pieces of software. So here's an example of the kind of software that you can use to create the infrastructure to build these chatbots. So for example, it's Kubernetes that a lot of people have heard about that. So Docker, and NoSQL like Redis. Openfaas is a framework to build serverless function using open source. Another piece of software could be RabbitMQ. That is a broker that you can execute in background some processes. Node.js is another form of service now, like executing JavaScript in the backend area. And MySQL is an old school database. This technology is TensorFlow. Prometheus is like a kind of software that collects your data, and you can query that data in a complex way. And Grafana, you can visualize that data. So the secret sauce could be have a container orchestrator like Kubernetes, have some serverless implementation like Lambda or that open source solution like openfaas, and some kind of NoSQL databases like Redis, Mongo, Cassandra. And finally, you have to monitoring and make some analytics on that data that you are collecting through the chats. So let's go in depth. The cloud, the first piece, you have to choose the right cloud for your solution. It depends on your needs. For example, some considerations that you have to do is if you are currently using some cloud provider like Amazon, Google, Azure, DigitalOcean, And if your corporation has a contract to use some kind of service with a cloud, like a third-party provider. For example, other consideration is the way to improve the development, the speed of development, the quality of your software, and it's for of course, spend less money in your infrastructure. That's the important thing for a lot of corporations. So, which is the right cloud provider? Depends on your needs and the nature of your application. So in the chatbots area, there is a kind of steps or a generation process. So the first step to build all the system is to build a GUI, like a chatbots manager, a GUI to create the chatbots, to manage them, to deactivate the chatbots, to modify the flow of the chatbot. The second step could be to create the logic using artificial intelligence, the steps, the JSON that I showed you, to create the model for artificial intelligence. The third step could be to deploy and to package that logic in a container, like using a serverless platform like openfaas. And the fourth step could be to logging and monitoring your collected information. So for the GUI, for that chatbot manager, you could choose something like Node.js or reactive technologies. So that reactive technologies permit you to show all the information in only one page. That's the reactive kind of languages, and they are very popular now, like React, Angular, and that things, and permit you to deploy your application only using S3. So you can spend a lot of money using instance, only publish your application on an S3 bucket. So you save a lot of money in that way. It's like a kind of new architecture that the people is using now. So there are a lot of technologies, Angular and React. They are using Node.js in the backend. So with Node.js, you can make something by hand, or you can use a framework like Angular and React. And you also can use Node.js for backend, for some processing backend side, like real-time applications, notifications, or something like that. And in the second step, like for the diagram, the logic, and the artificial intelligence model, you can use some NoSQL to record that rules like a program, more or less. So you can store that data in a key value databases. So in this part is TensorFlow. So in TensorFlow, there is a lot of kind of tools, algorithms to create some models, like neural networks, like forest trees, a lot of techniques that TensorFlow uses, and it's very popular kind of library. Just to say something, all these technologies, you can visit the official site in this site. So just to be a resource if you are planning to create an architecture or some application, you can check the link. And continuing before TensorFlow, there's a site that you have to deploy that serverless chatbot. You have to package that logic in some container, for example. So you have to package that like a kind of serverless function, for example, Lambda. For example, you can use openfaas. Or you have to create something by hand, like using Flask, or create an API that you can consume. like a web service, kind of, or REST API. So openfaas has a lot of options for that. It's a big framework. It's very easy to use. So openfaas is the way, like, more or less, that works Lambda. So with openfaas, you have, or you can implement that kind of architecture. So Kubernetes, of course, a lot of people is using Kubernetes. So openfaas can run on top of Kubernetes. So with Kubernetes, you can manage all your containers. Kubernetes is an orchestrator that manages and scaling all your containers, gives you some storage, and manages all the things about the containers. So the other piece is Docker, and Docker brings you like a kind of small virtualization to package all the things and create some microservices. Here's two links, Docker and the microservices.io. Microservices.io is very interesting because if you are using Docker, it's not the same that you are creating microservices. It's different. So microservices is an architecture, and you have to learn the patterns to create microservices-based applications. So it's not the same. To create a container, it doesn't the same like you are creating microservices, but it's a tool to create microservices. So another piece of software is Rancher. There's a GUI panel to manage your Kubernetes cluster in a fast way, in an easy way. So it helps you to monitoring your implementation and to implement some CI/CD pipelines, to implement some DevOps best practices and that kind of thing. So Rancher is a fast way to implement or to use Kubernetes in an easy way. So MySQL is a popular and powerful database to manage information, so you can use it to store that information. And Redis is another NoSQL database. For me, it's the base of this solution. So it has a really fast access to the data, like 1 million per second of instructions that you can process at a time. So Redis is like a kind of, not a multi-purpose database, but it's very different, has a lot of types of data, like lists, like sets, live streams, like hash tables. You can do a lot of things with Redis. There's some specific use case to use Redis. In the first step for logging the chatbot information and monitoring, you could be interested in store all that data in a data lake, so you can perform a heavy big data analytics in your platform, but you have to use a broker to create that background processes because are very heavy. So you can use RabbitMQ, for example, ActiveMQ. There are another kind of software like Celery that is used by Instagram. So with a broker, it's designed to send and receive messages, but you can create some kind of worker inside. So it's very powerful to use a broker. For example, there is another kind of software that is similar. It's called Kafka. So maybe Kafka is more popular. So to collect or process data is Prometheus. So Prometheus, you can storage all your data for your serverless functions. And finally, the last one is Grafana. with Grafana, you can easily made a kind of visualization of your data almost in real time. So here is all the architectures, putting all together in a diagram. So here is the diagram of the solution. There are three solutions. This one is the open source serverless solution. For example, in this part, you can deploy all the Kubernetes cluster. So there is Docker behind, Kubernetes, and you can deploy that Kubernetes in Google Cloud, in Azure, DigitalOcean. There are different kind of service of Kubernetes, for example, in Amazon, like the AKS, but AKS is sometimes very expensive. Like, I remember that it's $144 to take that master for Kubernetes, so it's very expensive, but has some availability, so that's the cool thing. So you can pay AKS in AWS, but if you want to spend less money, you can deploy your Kubernetes cluster using a software that is called kops. So with kops, you could deploy a Kubernetes cluster. Google Cloud, Kubernetes technology is created by Google, so Google Cloud has the best support for Kubernetes. Definitely, it's cheaper than AWS, but it depends on what cloud provider are you using. So in that architecture, imagining that you have a master AKS or a master from scratch deployed using kops. So the big challenge is to spend less money. So you can use two kind of instances that could exist in Google Cloud and Amazon. They are similar kind of products. One piece of that is that there is a spot instance, like a kind of cheaper instance that have, for example, the cloud provider has some space that they are done using, so they pick that space and sell you for the virtual machines. So in AWS it's called the spot instances. In Google Cloud has another name, but it's the same concept. So you can mix your on-demand instance that are expensive compared to the spot instance. So you can mix that kind of solution to spend less money when you are creating a Kubernetes cluster. So we are building this system step by step. So first here, we have all the Kubernetes cluster. On top of Kubernetes cluster, you have to install openfaas. So openfaas run like a pod, more or less, like 5 or 6 pods, and gives you all the abstraction to create serverless functions. So with this serverless function, you connect that serverless function or a container that is public with the API with your favorite instant messenger like Telegram, Facebook, WhatsApp, yeah? So in this side, you connect your system with the API of that service. That's called to set the webhook of the application. So in this other side, you have the GUI that creates the chatbots. So that GUI generates some JSON information. For example, in this side is an example of that JSON. So your mission is to create an application that generates some kind of JSON that is kind of interpret and running in a real time. So for example, in the application that I made that consulting for a big telecom, they generate this kind of JSON. For example, you have to manage all your your bots, setting some ID to identify different bots, put it that name, maybe a description. This token is referred to, let me show you. So that token, for example, in Telegram, in a specific case of Telegram, there is something called the bot father. So the bot father has childs. So every child is a chatbot. So with the bot father, you have or you can create a bot with this command. You can search at Telegram, this bot father, and you can execute like putting this in text and click it. And they say, all right, a new bot. What name do you choose for that bot? So for example, OSCOM Wednesday, for example. And then you have to set a public name to access that bot. For example, OSCOM web bot, for example. There is no brain that processes all the instructions that bot, and you can access or search in Telegram, for example, like the name is called OSCOM Wednesday bot. So you can access now that bot, where you have to create like the brain behind that bot. So the brain and the infrastructure of that bot is the thing that I am explaining, and how it works and how you can scale that brain. So the brain is based on some kind of program made by JSON in this case, but you have to create something that is according of your needs. So in this example, it's like a kind of program, a sequence program. Like for example, outprint is like the regular print that shows you information in a chat or in a program. For example, this chatbot asks for your name, yeah? And you read information of your chatbot and all different things. So the GUI, yeah, you have to build it. Rancher to manage that cluster, and then the NoSQL databases like Redis or MySQL. So another solution is that you have to use Lambda. You don't have to build a serverless framework from scratch, just use Lambda. It's another solution. And you pay your Lambda functions and connect that API using the API gateway of AWS. And it's very similar. So the first solution is like a kind of from scratch. The last solution to evaluate could be Fargate. Fargate is like a kind of proprietary orchestration that do the same of Kubernetes that Kubernetes do. So Fargate is really expensive, but there are some good things and bad things about one of these solutions. So the trend is to deploy some small parts of code as a functions on a platform that is ready to run. So it's Lambda, for example. That's called serverless, like function as a service. Another important thing is that container orchestration and microservices architecture provides you a fast way to build auto-scalable systems and easy to upgrade modular systems. So you can speed your development time. You don't have to waste time configuring your infrastructure. So the order of evolution of the systems are microservices. The next step is the cloud native. And the last step is the serverless function. So serverless function is like the new kind of architecture that the people are coming to use. So the goods and the bads about the open source solution is that you have to struggle managing your Kubernetes cluster, scaling and monitoring. The bads of using a cloud provider of fast functions, there's a limit time of word and job execution. For example, Lambda only has like 900 seconds for execution, and that's it. If your process passed that limit of time, Lambda doesn't work for you. So there's the goods and the bads. And using, for example, Fargate, the bad is that really expensive. Yeah. The goods of an open source solution is that you can optimize all parts of the system. There's a full customization of the system. And if you use a FAS with a cloud provider, it's very cheap. For example, Lambda, only you pay for the request, not of the lifetime of the instance. So it's very cheap. And the goods for the managed orchestrator, there are some level of customization, and you don't waste time managing that infrastructure. So there are DevOps tools, or openfaas, Rancher, and Docker and Kubernetes are tools that help you to implement some DevOps processes, best practices, and that kind of things. So the demo, that's the important thing. Here are the pieces. This is a demo for the serverless architecture from scratch. So here you have the Kubernetes cluster. Yeah. Has 4 nodes and a master. This cluster is deployed at DigitalOcean. You can deploy with Rancher. I am using Rancher. So with Rancher is really fast way to create clusters. For example, you can create your cluster with Google Cloud, and you don't have to learn how to deploy that cluster. Rancher help you. So you can deploy on Google using AKS, Azure. In this example, I import the cluster made by DigitalOcean, or you can create your cluster using only instance, or another options, for example, VMware or your virtual machines from scratch. So here is the Grafana that is connected to openfaas. Openfaas is here. Openfaas lives here in the chatbot section. Openfaas is like a kind of different containers that integrates, that gives you that kind of abstraction, has a gateway like the API gateway of AWS. Here is called gateway. You can work together with Grafana to visualize your data. There is a way to expose your function. Like, for example, here is openfaas. You can deploy your functions. Here are examples of functions that you can create, or you can create your custom functions. So like the function is more or less like a container in openfaas. So if openfaas don't have a template to create the thing that you need, you can create a custom container to create your fast function. So there is not limit of time. You can set the limit of time of execution of a container, and you can scale from 0 to some number of containers. So that's the way that openfaas works. So in this side, for example, the pipelines, a rancher could help you to create your, well, it's a very simple way to create your pipelines. So you can create your container, deploy it to Kubernetes cluster, and add steps. Or for example, if you are using Docker files, you can implement some kind of continuous integration using Docker files. So it's very powerful. It depends on your imagination or your creativity to create that system. So finally, here I have a bot that is called OSCOM bot. So the OSCOM bot, I want to show you something. For example, here you can see that here's an OSCOM bot. So this OSCOM bot is a container that is managed and is published using the API of openfaas. And that API is a container that is public. So now, uses 0 pods or, for example, 0 containers. There is no using resources. So when I enter to Telegram and I write to that chatbot, they create the container. And they kill the container for some time. That's the way that serverless functions works. So in this way, you create all that thing by scratch, like your own Lambda. So let's search that bot, OSCOM bot. So let me delete the previous conversation. So OSCOM bot. Here's the OSCOM bot. You have to start in Telegram. So when I enter here, they create the container. And openfaas can create or manage the amount of containers that help you to process all that information, all the recurrency, that kind of things. So now, if I come back, they execute this logic that is created or interpreted by this JSON. So this JSON is transformed to an NoSQL database. In this example, they convert that logic in a set of rules that is stored in Redis. So here is the step and what the step do. For example, the action. In this node is a read and read a name. For example, here the action is to print and show a message. So if we finish to run this bot, I send my phone number here and say, welcome to OSCOM. Hi, how are you? Tell me your name. Well, my name is Sergio. Oh. My name is Sergio. So choose a day to see the schedule. Today is Wednesday. Well, it's more important to see it Thursday, tomorrow. So building machine learning inference pipelines at scale, that time. So have a nice day. Please evaluate my session. Don't forget to post with OSCOM hashtag. So then they launch the artificial intelligence. The artificial intelligence uses these patterns of information. For example, if I want to search something like, well, begin, start, or init, they send me to the beginning of the bot. For example, but this is not a string comparison. They use recurrent networks. So use the model of artificial intelligence to detect that I am writing that. And they send me to that flow. So For example, if I write, what do you want to search? Begin, for example. And then I found start. So go to, and they send me to the start of the bot. So welcome to Oscom. Hi, how are you? So that are all the pieces of the system that you can build from scratch using openfaas and all that pieces of software. And thanks. I don't know if this is time for questions. There? Do you have questions? No? Somebody want to ask something? Well, the main idea of this session is there are a lot of technologies. Yeah? I think, or I know that is a lot of information here. But your assignment is to see all these technologies and design which technology, or choose which technology is right for you. For example, I want artificial intelligence. Well, it's TensorFlow. For example, I want to use Kubernetes or containers, sorry. I can choose Kubernetes. Well, so in the corporation, there's a contract to use AWS. Well, I need a speed in my chatbots. So I can test Lambda, and I can measure that speed. If it's right for you, Lambda is the right solution for you. If you need more speed, you can try Fargate. If Fargate is too expensive for you, you can choose, for example, instances, or make the solution from scratch, for example. And these all the pieces you have to evaluate which one is right for you. And these diagrams are like the idea of how to create that architecture. So that's the main idea, to put all this information in the presentation. So if you want the presentation, here is the link, because I know there is a lot of information. You can write that link. If you want, you can contact me. You're taking pictures. So you want to write something, write me at LinkedIn. You can find me like Sergio, Ariam, GPL. So thanks.